Okay, I wanted to finish up section 9.2 in this video. In 9.2, we're just going over some information about the main thing is our law for rational exponents. Okay, so here's what we have to know about that. A to the m divided by n is the same as the nth root of a to the m, or you can do the nth root of a, whatever that is, and then take care of the power of m at the end. There's other laws of exponents that we should know. Okay, this is kind of like we've been there and done that before. Here's they're introducing a new law to the list. All right, so we did a couple of calculations and showed some things on the calculator here, and I'm on problem 16. Now, remember from earlier, the square root of x squared is the same as the absolute value of x. The square root of a number is never going to return a negative. Like if I ask you the square root of 9, that is 3, not negative 3. Okay, although x could be a negative. So if x were like negative 3 squared is 9, and the square root of 9 is 3. Okay, the absolute value of negative 3 would be 3, so I'd still get 3 as an output in the calculation. Now, x squared to the 1/2 in radical form is the same as the square root of x squared. So if I wanted to compute x squared to the 1/2, I'd want to make sure that I know this rule here, that I'd get the absolute value of x. Okay, unless I was under the assumption that I'm going to assume that all variables represent non-negative numbers. Okay, if I'm already assuming that x is not a negative, then I don't need absolute value bars. Okay, if it just said simplify, then I would need to make sure I have those absolute value bars in my answer, otherwise it is wrong. Now, again, more times than not, for most of the problems in this chapter, they're going to say simplify and assume that all variables represent non-negative numbers. Okay, but be careful about that, because if it just says simplify, you'd want to make sure that you're using absolute value notation if it's necessary. Okay. Let's take a look at part B. So how about the negative 32x to the 15th to the 1/5 power? Okay, well here'd be what that looked like in a radical form. The 5th root of negative 32x to the 15th. Okay, now when simplifying radicals, the plan is to have the index and then the power underneath match, because then those two items are going to go away, right? And so that's what I'm doing here. I know negative 2 to the 5th is negative 32. X cubed to the 5th would be the same as x to the 15th. So negative 2x cubed, all that to the 5th, would be the same as negative 32x to the 15th. The 5th root of something to the 5th power means that the index and the power of 5 will go away, and going to leave me with just negative 2x cubed then as the answer. All right, here's another one, part C. X to the 8th, y to the 4th, all that to the 1/4 power. Well, in radical form, I'd have a 4th root of x to the 8th, y to the 4th. And I'd want to rewrite that so that I got the 4th root of something to the 4th power. X squared to the 4th, that's the same as x to the 8th. And then I've got y to the 4th there. So x squared y, all that to the 4th power, would give me x to the 8th, y to the 4th. The 4th root of something to the 4th power means that the index and the power will go away, and that's just going to leave me with x to the x squared times y then as the answer. Another option, which would be quicker, would be just to multiply the powers and then reduce. Okay, so if I did that, x to the 8th, y to the 4th to the 1/4, well, multiply the powers. 8 times 1/4 would be 2. 4 times 1/4 would be 1. So I'd have x squared times y to the 1st, or just x squared y. Like, I'd still get the same answer. Okay, and of course it'd be faster, I think, to just multiply the powers together. But if I look at it in a radical form, this would be also another option that I could consider. Really what's going on kind of behind the scenes there. Part D, okay, let me just multiply the powers together. 18 times 1/6 is 3. 24 times 1/6 is 4. 30 times 1/6 is 5. So this expression simplifies to be a cubed b to the 4th c to the 5th. Done. Okay. Of course, I could look at it as a radical calculation also. You know, I'd have a 6th root of something to the 6th power. That something would be this guy here, a cubed b to the 4th c to the 5th. Okay, like I'd still get the same answer if I were to go through the calculation using radicals. Here's another one. Okay, and I'm going to rewrite this in a radical form. So m is 3, n is 5. I'm going to have the 5th root of 243x to the 10th cubed. Okay, now underneath the radical, I'd want to rewrite this expression as something to the 5th power. That way the index of 5 and that power of 5 will offset each other. 3 to the 5th is the same as 243. X squared to the 5th would be the same as x to the 10th. The index of 5 and the power of 5 will go away for me now, so I just have 3x squared cubed. 3 cubed is 27. X squared cubed would be x to the 6th. So 27x to the 6th, that'd be my answer. Okay, here's another one. Again, you know, if you're able to just multiply powers, that'd be a quick option. So x to the 6/7, y to the 3/8, all that to the 2/3. Well, 6/7 times 2/3, that would be 12 over 21. 3 goes into 12 4 times. 3 goes into 21 7 times. So that exponent would reduce to be 4 over 7. And remember what I said earlier about always reduce the exponent. Okay, so like you wouldn't want to leave it as x to the 12 over 21. Like anything else in math, you know, simplify as far as you can go here with this stuff. Y to the 3/8 to the 2/3, okay, you're multiplying the exponents. The 3's will cancel there, right? And so that's going to leave you a 2 over 8, which again you'll want to reduce to be 1/4. X to the 4/7, y to the 1/4 then would be the answer on that one. Okay, here's another one. Multiply the exponents. 18 times 7 divided by 2. Well, 18 divided by 2 is 9. 9 times 7 is 63. 12 times 7 divided by 2. Well, 12 over 2 is 6. 6 times 7 is 42. And then 20 times 7 over 2. 20 divided by 2 is 10. 10 times 7 is 70. Of course, whenever I'm multiplying or dividing, I can bring the exponent into each and every term. That was these two laws here. Now, never ever if you're adding or subtracting, okay? So be careful about that. I don't have any addition or subtraction going on in this problem. Part H, okay, so some students would make the mistake here, and they see this exponent of 0, and they know that anything to the 0 power is 1, right? That's one of our laws here. That's law 7. Anything to the 0 power is 1. And they would just say, well, the answer is 1. You're not raising this entire thing to the 0 power. You're only raising y to the 0 power. So the way to look at this is you got x to the 2/9 times 1, which is x to the 2/9. Now, if I had parentheses around that, okay, yeah, anything to the 0 power would be 1. So x to the 2/9 y, that whole thing to the 0 power, that would be 1. Okay, here's a great example of notation. You know, yeah, I mean parentheses matter, right? If we don't write the parentheses, like it doesn't mean the same thing. We don't get the same answer. Here's another one. Okay, so remember law 1 for our laws. Whenever you have whenever you're multiplying, you keep the base and add the powers if the base is the same there. So that's what I'm doing here. I'm going to keep x and then add the powers. 2/5 plus 1/5 would be 3/5. X to the 3/5 in a radical form would be the 5th root of x cubed. Okay, now pay attention to how your book wants the answers written, or how my math lab wants the answers entered in. Okay, because on some of them, they'll want you to type in the answer using radical notation. Okay, well that's what I've got circled here. In other problems, they'll want you to type in the answer using rational exponents. Well, then I want to type in this guy, x to the 3/5. Okay, if I type in this radical form and they're asking me for rational exponent form, I don't have the right answer then, right? Because I didn't follow directions. So be careful about that. You know, make sure that you're reading the directions and that you see the form that they want the answer to be presented in. Here's another one. Okay, so if you're dividing expressions and the base is the same, you're going to keep the base and subtract the powers. That's law 2 on this list. Of course, 3/6 is the same as 1/2, right? That's easy enough. X to the 2/3 divided by x to the 1/5, it's going to be x to the power 2/3 minus 1/5. So I've got a side calculation, 2/3 minus 1/5. The common denominator is 15. 2/3, that's same as 10/15. 1/5, that's same as 3/15. 10/15 minus 3/15 is 7/15. So 1/2 x to the 7/15. That would be my answer if I were to, leave it in a rational exponent form. Here's another one. Okay, part L. I'm going to keep the base and add the powers. Okay, using law 1 on that list. So I'll keep the 16 and then add the powers. Negative 3/4 minus 7/4 would be negative 10/4, which is the same as negative 5/2. Of course, reduce that. And then I'm going to rewrite this expression so that the exponent is a positive using law 8 here. 1/16 to the 5/2. Okay, now I got to know what is 16 to the 5/2. Well, in a radical form, that would be the square root of 16 to the 5th. The square root of 16 I know is 4. 4 to the 5th would be 1,024. Okay, 4 times 4 times 4 times 4 is 1,024. So 1/1024 would be my answer in an exact form and also in a complete simplified form. Okay, we got 2 more. Part M, the cubed root of x times the 4th root of x. So a lot of problems in this section start off where you have something in a rational exponent form, and then at some point you need to use this law here, the law for rational exponents, where you rewrite it into a radical form. Okay, and so that's what I've had to do on several of these actually. But I don't want to do that here. Okay, I can't combine these to a single radical because the index is not the same. So in doing this problem, I'd want to rewrite this radical form to a rational exponent form. If I did that, then the problem becomes just like this one here, where I'm going to use law 1 on that list. I'm going to keep the base and add the powers. 1/3 plus 1/4 has a common denominator of 12. Okay, and you get 7/12 then. So x to the 7/12 would be my answer if I were to leave that in a rational exponent form. That's the only way to do that problem, by the way, is to look at what these radical forms look like in a rational exponent form. And that's how I want to do this last problem here also. The square root of a divided by the cubed root of a. Well, the index is not the same, right? So I can't combine these. There's nothing I can do with simplifying if I stay in a radical form because the index is not the same, like I said. So I'd want to rewrite the numerator and the denominator into a form that involves rational exponents. The square root of a, that's the same as a to the 1/2. The cubed root of a, that's the same as a to the 1/3. Now I'm going to use law 2 on that list of laws, where I'm going to keep the base and subtract the powers. Okay, I'm going to get 1/2 minus 1/3. I did a kind of a side calculation with that. That gives me 1/6. So a to the 1/6 would be my answer. If I were to leave that in a rational exponent form, if the book was looking for radical form, then of course I'm not done, right? I'd want to rewrite this into a radical form. Okay, the sixth root of a then would be my answer. So again, make sure that you're paying attention to the form that the book wants the answer to be written in. All right, that's all I had then for this section. The homework is on page 706. Be sure to look at the odd-numbered problems on that page.